Okay, hello everyone. Welcome to this online introduction session about the Master of Material Science and Engineering. And before starting with the content of the presentation, I think it's important to introduce the team. First of all, Timo Müller, he's in the background and he's a student in applied science and helping us in the production of these online sessions. We have Jauke Bloem as a master in our program and board member of the Student Association, Tuvalheim. And he's here today to moderate the QA session and also he will try to answer your questions during the presentation. And me, I am Yaisa González Garcia. I am the coordinator of the Master Material Science and Engineering, and I'm an associate professor in localized corrosion and electrochemistry. Please, during the presentation, you can place your questions in the QA chat, and also at the end there will be time to complete or to have if you have more questions, we can try to help you and give you your answers. I prepared a presentation to give you a bit of a general view of a program, and I will divide it in 3 blocks. I will start with the general introduction about what is material science and engineering, and then I will go to the explanation of the program with some general, maybe a description and characteristic of the Master of Material Science and Engineering, and in the final part I will give a bit more in detail information about the courses and the structure of the whole program. The first is what is material science and engineering, and this discipline is a very fascinating and complex area that studies the design, manufacture and process, microstructure, performance and properties, and recycling of materials. It's a multidisciplinary field because it includes elements of physics, mathematics, chemistry, biology, economics, engineering, all around material science. It's also quite complex because the studies of material science cover a broad range of length scales, and we can go from atomic scale all the way up to a larger scale of final application in which you can have large components or large structures. As you can imagine, everything is made of materials, and therefore material science is very relevant. And normally we hear that material science can be the bottleneck of modern engineering and developing new technologies. And this is true. If you want to supply, to provide or move forward in technologies, we need to innovate in materials. And actually materials are essential to give solutions to challenges in society and also support industrial top sectors such as energy, new energies, infrastructure, technologies, health and life, automotive, and so on. If you have a look, maybe in the European Union, in the websites, in the governments in Europe, if you have a look to the current global grand challenges that we are looking in our society, you can actually see that materials plays a crucial role in all these challenges. And here, without much in detail, what are these global challenges? You have sustainable cities, climate change, global health, food, water and energy, digital transformation. In all of these, materials plays a role. And I can give you 2 examples. For example, in health, we have to deal now with the increasing of aging in the population, and you need to tackle their needs at an affordable cost and more efficiently. And a clear example of that is the application of implants and joining replacements. At this moment, we need to develop new materials that offer better biocompatibility when you introduce in your body, low friction. And also we should find solutions that allow us to design these implants that give the specific or supplies the specific needs to the patient. Another example can be in energy application of sustainable energy sources. You think about photovoltaic cells or wind energy. In this case, we are now confronting a high demand of these energy sources, and this requires better functional and structural materials to sustain these sources, but also innovation in materials that help us to increase the efficiency of the process, the reliability of the process, and within a good margin of cost or cost reduction. As you see, the importance of materials, and within all these aspects of material, I think what is relevant in the last decades and becoming very crucial in the future is that we need sustainable solutions, and sustainability should be present in the whole life cycle of material. And this is what I show in this picture. By sustainability is we have to find efficiency in process and application, more alternative to a scarce of limited raw materials, and facilitate solutions for better reuse and recycling of materials. With this, I would like, with this kind of a summary, I want to show you the importance and the relevance of material science and engineering, and our position in our department. I have to say that in the Department of Material Science and Engineering, we cover in research and in expertise all the life cycle of a material, and we really pay close attention to sustainability. And this is reflected also in the program. And that brings me now to the part of what you are interested in, the Master of Material Science and Engineering. And I would like in the next slide just give you some flavor of what is the master. The first thing is a unique master in the Netherlands. There is not any other program that offers material science and engineering as a core content of a master. And during the studies, you will learn, or you will get in-depth understanding of the main classes of materials. And especially we focus on metals, polymer, and ceramics from nano to larger scales. I again show this diagram here because we try to keep present in the content in the different courses, in the different aspects of materials, we keep present the importance of sustainability. While studying in the master, you will have the chance, or you will be introduced to scientific challenging topics. And indeed, we have a strong background in science, in material science, but we never forget the contact to the industrial application. That's the reason that you will be introduced to scientific challenge, but with a clear connection to applications and solutions that can be applied in industry. That's the reason that during the master, you will have numerous opportunities to interact with industries and also with experts in different fields in material science and engineering. One of the main characteristics of this program is that we normally have a relatively small group of students. Every year, lately we have around 60 students. That is an excellent opportunity to get to know each other during the 2 years program, but also to have a closer or better interaction with the staff and docents. Another peculiarity of this program is that it's quite international. From the staff and docent team, which we have quite diverse number of nationalities, but also in the student group. And we have every year students from many different places. That gives us actually an interesting and very friendly dynamic during the lectures, but also during the time outside the lectures to interact with your colleagues, researchers, and also staff. I think let's go to the main, the core part of the presentation, which is the program. This is a 2-year master, and to obtain your diploma, you have to fulfill at least 120 credits. This 120 credits are divided in 3 main blocks. Let's say you have the core program, in which is a selection of courses which cover 41 credits. Then you have the room to specialize in a specific thing, and this will be 34 credits related to the specialization. And the final block at the end of your master, which is the master thesis, which is a research project in a relevant topic. In the next couple of slides, and basically the rest of the presentation, I will try to give you a bit more details about these 3 blocks without going much in depth about the content of the courses. But of course, you can always ask, and we can try to reply you in the chat. Before that, just to show that how it looks in the 2 years plan, you will be busy mainly the first semester and a bit more in the second semester of the first year in the core program, which normally is quite intense. And you will start also some specialization courses. It means that already halfway of your first year, you will start already focusing on finding your desired specialization. The second year looks a bit different. You will have to finalize your courses related to the specialization, and then you have the part of the master thesis, which is divided in 2 parts: the review, the literature review, and the research project. What is the core program? We have 41 credits, and this is with a set of courses, and you see it's quite large. And the main goal of this program is that you set the base and the fundament or the milestones of what is material science and engineering. And this program will cover aspects related to sustainable approach on materials. And this is in this part here, we have society needs, in which you will have the opportunity to review literature, to learn about importance of sustainability on materials and so on. You will learn about ethical and social aspects related to technology. Then you will have a block of 3 courses in which you cover let's say the skeleton and the core part of materials, which is structure of matter, thermal properties, thermodynamic and kinetics, and also the main fundamentals of materials characterization. We try here to combine not only theoretical classes, but also you will have the chance to perform experiments in the lab, especially for materials characterization. Then you will dive in more in depth about the fundamentals of different types of materials, especially metals, polymer, and functional ceramics. And in the final block presented here, you will learn basics about computational material science, fundamental mechanical behavior of materials, and also how these properties are related to microstructure. And finally, the main aspect of production and processing methods and materials application. This is a core program, and of course we are material science, but we cannot cover all classes of materials in our program. Therefore, I think it's fair to mention that our primary focus on the program is metals, polymer, and ceramics. But doesn't mean that you have a chance to broaden up your interests and explore another type of materials, because you will see that during the specialization and the options to choose courses, you can always broaden and go beyond these 3 primary classes of materials. As I said, the second part is the specialization program. To complete the specialization, you need to have at least 34 credits, and basically the main goal here is that you go a step forward in your formation, and you get in-depth knowledge about a specific class of material or a specific thing within materials engineering. We have 4 predefined specializations, and that are highlighted here: materials and engineering applications, metal science and technology, materials for sustainable development, and advanced construction of material, which is given together with the civil engineering team. Of course, it may happen that these themes are not within your interest or doesn't fulfill your curiosity or your professional interest. That's the reason that we also offer the opportunity for the student to define their own specialization. Within these options, and I will go one by one just to give you a short description, just to mention that how it looks, the specialization within these 34 credits, you have a core part or obligatory part, which should be around equal or more than 14 credits, depending on the specialization, in which you will have a selection of courses which are focused in a specific area, and then you to complete the other the program in 34 credits, you have room to choose them amongst recommended elective, other elective. You have opportunity to choose courses from another program, master programs in the university or in other universities, but also you can carry out an external research project, which is kind of equivalent to an internship in industry or in other institutions. Then you see already that it's not a closed program. You have room from the specialization to find your way and to select your to find your interest and develop that. Just to give you a nutshell, materials and engineering application, as the name say, you will see application of materials in different areas, aerospace, maritime, in technological industries, and automotive. You will see a different aspect of materials, and the core program in this case consisting of 2 obligatory courses, science of failure and corrosion engineering. And in here is, as you see, you will learn the properties and behavior or performance of materials, mechanical properties and corrosion properties. And you will have then to choose among the other 4 courses to complete the core program of the specialization. And you see that the list of courses cover different aspects of this topic. We have joining technologies, advanced characterization of materials, material selections for engineering application, which gives you an idea of how to select a matter depending on the requirements of the component of the industrial application, and so on. Then basically the core part of the specialization, you will have 2 obligatory, and then you will have to choose among these. The next specialization is metal science and technology. And here you shift a bit from the application, and here you go more to the fundamental understanding, and especially in metals. That's the reason that you will go a bit more in depth in metal design and properties. The core part is focused on mechanical properties and metal science, and then you have room to complete that core with another aspect specific in steel science, corrosion science, advanced computational materials, or advanced characterization. Moving a bit now to the aspect of sustainability, we have the specialization of materials for sustainable development, and in here you will learn materials engineering in the context of sustainability and environment and environment impact. We have 2 courses that cover recycling engineering of materials, which actually shows you recycling procedures, physical metallurgy, and also industrial cases, and then materials for clean energy technology. And you will see example of photovoltaics and wind energy. Of course, then you have the option to complete the core with another applications, and you have here materials, for example, materials at high temperature. The 4th predefined specialization is slightly different because the core part is already defined, and these are 4 courses. And in this specialization about advanced construction of material, basically you will learn modeling and experimental aspects of materials for advanced construction application. And you will see now that the courses are more specifically for a structure point of view. We have concrete science and technology, repair and maintenance of materials in construction, forensic building materials engineering, and the part of computational modeling. Of course, as I said, you may not be fully satisfied with this topic. That's the reason you can create your own specialization. The only requirement is that you have at least 14 credits following a common theme or a common topic, and it can be a specific material class or another application. The beauty of, let's say, the advantage of that you can really select courses from another faculties and other fields, and you really can create your own curriculum. It has you need to pay attention to some difficulties about clashing between courses, but it's a bit something to discuss. But in general, you are free then to choose your self-defined, and it should be approved by the Board of Examiners. Just to give you an example of a specialization defined from students in previous years, if you have interest in composites, you can focus on the manufacturing, characterization, and application of composites, lightweight materials, or materials for specific applications such as aerospace or nanotechnology. Again, in a nutshell, we have different specialization. You have to define your core, but you still have more room to choose between elective and different topics. I bring this slide here back because, as I mentioned, you have many courses, but also you have the opportunity to do the external research project. The external research project is 15 credits, and basically is a project that is that takes place in an industry or a research organization outside of TU Delft. It should be a research project with certain research question or research case, which can be finalized or closed within the time that is agreed. Here I just try to show you that within our master we have connection with many industrial partners, and these are many of the companies in which the students are following their research external projects. You see companies such as Tata Steel, AkzoNobel for coatings, SML and NXP for advanced materials and electronics and semiconductors, KLM for aerospace application, Toyota and DAF in automotive, and so on many of them. Not only industry, but also you have the opportunity, if you wish, to find a project in research institution. And here just two examples in TNO in the Netherlands, but also CERN in Switzerland. And also you can find if you are interested in universities within in the Netherlands, but also abroad. And there are we have some students in the previous years going to UK, to the Imperial College in London, and even to China. After finalizing your specialization, you reach now the last stage of your master, and this is the master thesis. The master thesis is consists of 2 parts: an extensive literature review in which you summarize the state of the art of a topic, but also identify critically the knowledge gap, and the research project in which we have research or scientific questions that need to be answered, or you need to bring a solution to an industrial case. This master thesis can be done within the department in collaboration with other departments in TU Delft and other universities, but also in collaboration with the industry. I just have to quickly 2 short slides just to give you some examples of topics which have been studied in previous projects, and maybe an example related to electronic devices and solar cells. Normally, this type of systems consist of multi-layer thin film materials, And they are one of the challenges, the bonding, how is the attachment between those layers, but also the possible failure. And it has been some work done, for example, for semiconductors and the effect of temperature and the failure of bonding between aluminium. And a typical case also for electronic devices is the effect of humidity and environment. Then the research was focusing on trying to understand the failure of these thin films. Another example is the application of computational materials to optimize a process. And here is an example of optimization of aluminum anodizing. Aluminum anodizing is a typical finishing of aluminum substrate that allows us better mechanical properties, also durability, and it can also facilitate the application of coatings. And basically here was a modeling on a way to optimize that you have a better growth of that oxide layer. Another example, more recently, the application of 3D printing technology. And the 3D printing of material, specifically metals, allow us to create very complex geometries more efficiently, but also give us room to actually tune microstructure, to tune the microstructure in order to achieve certain properties or desired performance. We have several master projects in this topic for biomaterials application, for example, in which you need certain mechanical properties, but also for larger structures in the engines and propellers in a boat, in which it's important the processing parameters of the 3D printing to achieve the required properties. Another example is also the application of artificial intelligence for the design of new materials. And here I bring this project from last year, in which a student apply machine learning, actually data-driven design, machine learning to applies machine learning to achieve a super compressible metamaterial. Just to mention that this work was a collaboration with material science and aerospace faculty, and the student was awarded with the Tata Steel Award for the best graduate. And just to see that, it is also, I show you that it's a relevant topic for industry, but also it has an impact in society and high visibility. In general, we offer the master thesis is there is room for many possibilities, and the main message is that you decide the topic in where you want to work, and we try to help you and to find the right support for that. There is also international opportunities. I mentioned that you can study abroad or to do your project also abroad. Maybe important, what happened after you finish your master? Normally, when you finish your master in material science and engineering, you will gain some expertise that can be applied in different fields, in production and scientific research, innovation, production, improvement, management, consultants, and so on. Within our students, we see a high percent of students going toward industry, and you see here which type of organization: high-tech industry, steel, aluminum manufacturing, but also more recently in energy sector, polymer and recycling industry. Of course, there is still a small percent that would like to go more in the academic career, and they pursue a PhD position. And this can be within our department, but also somewhere else. I think I don't need to show this. Is just as a kind of an overview where the students has been, but in general shows the highly presence in industries and then in small companies and so on. For the admission of our master, normally you will have for sure all the information in the website of the faculty, but if you are a Dutch students with a bachelor from the university, normally you should have appropriate background and let's say equivalent in mechanical engineering, marine technology, aerospace, applied physics or chemistry or chemical engineering, and these are eligible bachelor for admission. If you have a different bachelor and they need to be, or you are coming from an HBO degree, then it needs to be evaluated to see if you are eligible for direct admission or you need to follow the bridging program. In the case of international students, again, you need to have a bachelor background. That should be suitable for our master, and there are more details in the website. In general, as you realize, it's a master, basically everything in English. Then you need also a good English level, English proficiency. In a nutshell, maybe to show you, I try to show the importance of material science and engineering. And in our master, let's say it's a study with choices, because you have many choices during the 2 years. And although the core focus on material science, you have within your specialization the room to broaden your opportunities, your interest, and also prepare your career in the future in industry or in academia. With this, I would like to thank you for your attention. You have here my contact details, and also you can always now ask questions during the QA. Thank you.
Thank you very much, Geisa.
Yeah.
I have a couple questions here that came in through the Q&A section. So let's start off with the easy questions that you can probably answer. There's some people here that were asking about their degrees, their backgrounds and bachelors, and if they can come. So I got questions from chemistry, chemical engineering, and I think aerospace. Can you comment on how easy it is to bridge from those programs towards ours?
Yeah, it's a good question. Probably I cannot answer all the specific cases. What we have is bachelors in mechanical engineering, marine, aerospace engineering, physics, and applied chemistry or chemistry normally have direct access. It means that you should have adequate level for the access. But it's true that it depends also of the university. Then that is the reason there's not a straightforward answer. Normally from the TU Delft, if you are a bachelor for those topics I mentioned, normally it's direct access. From another university, the best is to contact, you contact me, actually you can contact the coordinator, we can check the curriculum. And also you can check with the bridging program coordinator, and they can even have more specific information, because they can also indicate you which courses you need to follow for the bridging program.
Okay, thank you very much. I got a different question now that I found quite amusing. Can you comment on what the difference is between our master and the master chemical engineering? I don't know enough about chemical engineering to answer this question, but maybe okay. You can comment on this.
Well, chemical engineering, of course, it's still materials is present there, but I think in chemical engineering, you focus more on the process. You don't focus so much in the properties and the performance of the material. Normally, the material in there is kind of a support for the chemical process. Chemical engineering, I think you will find more examples. You go is catalysis. Synthesis of products, generating fuels and so on. Then, although material is present, but it's not so much about the structure, the atomic structure of a material, how the material will impact on with environments, or how will be the performance. I hope that helps a bit to clarify.
Yes, thank you very much. I have another question here from an anonymous listener who asks, how many applications do we get each year for this degree?
Oh, this is a good question. I have to make the math, because I have two sources of applications. Most probably around 200, 250 applications. We have many applications for international students. This is, I think, normally this is the number of applications that we get.
Thank you very much, guys. Then another question. I have a question here about a person who is more interested in the computational aspect and the aspect of sustainable materials. And can you comment on the rough percentage of our degree that relies on like basically our core program, how much the core program relies on microstructures and how these like microscopic properties influence macroscopic properties, and how much of the program we can actually freely choose and go in any direction we want.
Okay. Yeah, the core program, of course, it has a strong, let's say, I would say the core program has a strong focus on aspect of science. In there, then we talk about microstructure. And you will gain, I think this is the pillar, eh? You need to have these milestones, what is the structure of a material. You will talk about crystallographic structure. We talk about how those components then will influence in the process in the mechanical properties and so on. Then the core program maybe is a bit, let's say, the science part, the theoretical part. And from there, is the question, yeah, you can go to more apply. What is the percent? I tried to reflect, maybe it was not clear that you have many options. If you have an interest in sustainable and computational, you can create, you can find a bit of a balance of courses that can cover those aspects. Let's say the core program maybe is a third, or a bit more than a third part of the master. The specialization is another third, and then you have the master thesis, which is another a bit third part of that. Then I think it's quite balanced, I have to say.
Yeah, I would agree if I can just say that, like, you're so free in this, in our format that we follow here, that you can basically, if there is a certain part of material science that you don't like, but it is still critical to material science, like you will never have to spend more than, I'd say, like 10 or 15% of the course on it. Like something like this microscopic things is completely integral to material science, of course, and therefore you will not be able to not have any courses in it, but it's a very limited amount if that's not the part that you want to follow.
Yeah.
Okay, another question. About going abroad, and the question specifically is it possible to take courses abroad? And I'd like to amend that question with also internships and maybe graduation projects. So are courses, graduation projects, and internships possible abroad, Yaitha?
Yeah, in principle, yes. Courses abroad, it need to be checked by the board of examiners, and we have to check if it fits also fits in your plans and your education plan. But it's possible, and sometimes even encouraged. The same goes for external research projects and the master thesis. I have to say, master thesis, we don't have so many going abroad, and sometimes it's a matter of time schedule and the opportunities. External research project, yes, we have some examples. Therefore, the answer is yes, it's possible, and everything is just to discuss and need to be should be fitting within our scope and also your time plan. Yeah, maybe now in the Corona situation it's more complicated, but hopefully it change.
Or maybe it's even easier because of it, because we can follow courses from abroad, right?
Yeah, okay, now you can do everything online, then it's easier to do it abroad.
Yeah, and you can just, like, if you want an internship or something and it's like a multinational, it's of course possible to follow it both here and abroad, like whatever that company wants. So this is like very liberal in terms of all that. I have another question here. What is the contact hour to self-study ratio, Yaitha? And I think then it's mostly about our core program and not so much about the things you can choose.
I think maybe you are, Joke, the best to answer that. how you have experienced that. Because I can't talk about the credits and the hour expected, but maybe you have more hands about that experience.
Well, I don't know how much like I can actually say for like normal years, because for example, this year the lab courses were like we weren't allowed to go to the labs because of the corona rules of the government. So there were a lot of like contact hours, if you will, were lost by that. But in general, I'd say it's more self-study than in my bachelor personally. And so that would amount to like if your like normal work week is like 40 or 42 hours, I'd say it's like 60 to 65% self-study and the rest of lectures. Because like the core difference for me to my bachelor's is we don't have a lot of like classes where we do exercises together, like tutorials or seminars. It's mostly like you have lectures and then you can do exercises yourself. Not every course is different, of course, but this is the general vibe. So let's have a look if there's other questions here. Also, guys, just keep the questions coming. I'll try to read them out if I can come behind them. Okay, so I have a question specifically about a certain car manufacturer that uses specific composite materials to build their car and technical parts. Can our degree teach us about these specific engineering applications?
Yeah, I couldn't grasp exactly the application and the specific. Yeah, to be fair, I cannot say yes. Probably you will learn is that to understand the composite and the process, but yeah, it's a difficult question.
Yeah, exactly.
I probably you may tune if you know exactly what you're searching. Maybe you can have a look to the courses and maybe specialize or try to tune it in that direction. But it's very difficult to find a master that will focus specifically in that application.
I agree with Yaisa. In general, like, I don't know about your specific application that you are looking for, but in general, there are courses here on composite materials and also lightweight structures, often taught by the aerospace engineering department. And you can follow those courses. I don't know how much in detail they will go about like car parts and specifically like the material that you described in this question. But you can follow courses on composites and other lightweight, high-performance materials. I hope that answers your question. Okay, then we have another question about the literature review, the part next to our master's thesis. Can you elaborate a bit on what that means?
Yeah, definitely. The literature review is a bit of new because now you have like separated from the research project. And maybe just the definition, what you do in the literature review is you actually check, review, and check the scientific literature available about a specific topic. And this is the main question. You need to first decide what is the topic of your literature review. And what you try to do is to summarize what is the state of the art, what is the situation, what we know about that topic. And from there, you need to comes the difficult part because you need to then discuss what is the knowledge gap, what is missing, what needs to be done to continue to solve that topic. How it's in practical, you will have basically a integrate is around 2 months of working in your review. You select the topic of your interest, and you need to come out with a report in which just have this part, the context, and also the state of the art and your discussion. And also you have to give a short presentation about your main findings, because also give you a room then to come out with a discussion and answer questions to other peers.
Thank you very much, Yaisa. I have a question here. Can we go beyond the limit of 120 credits? Like, for example, can we do an extra internship or courses outside of the program before we start our thesis?
Yes, it's possible to go beyond the 120, but there is a bit of a constraint, and this is coming from the Board of Examiners. Normally, we say that no more than 6 to 8 credits above this 120. The main reason for that is that you still need to, ideally, to finish in the 2 years program, and it's always good to keep a track on that. But imagine that you have a strong motivation because you have a good reason to go beyond this, even 8 credits. It's always something that need to be can be discussed with the board of examiners, and it's case-to-case basis. But the recommendation is, yes, you can do more, but not more than 6 or 8 credits above the 120.
Yeah, actually, I tried to do more credits, and I got an email back from Yaisa saying, hey, this is not okay. You're doing too much. So it is possible, but like, please don't overwork yourself. I guess that's ultimately what it boils down to.
I think that is the main message, and again, there is still a flexibility, and you can say, I ignore that message from Yaisa, and you enroll in some courses. Yeah, then of course they can be considered, but the main message is don't overdo, and you should have a plan that is feasible in the 2 years.
Yes, I have a question here about scholarships. Do you know anything about scholarship opportunities, maybe from TU Delft or even from our department?
Yeah, I think this is probably coming from an international student. If you want to know more about that, contact the 3ME in the contact center. But indeed, there are some. There's a fellowship or a scholarship for the master that actually covers you the full master, and I think it's quite limited, because I think this year we offer only 3 scholarships for the faculty. It means for the whole for the 8 masters that are offered. Then it's quite demanding. My advice: just checking the website and contact the contact center.
Okay, I have one question here by an alumnus of a materials science bachelor, and I was asked about the overlap between like a material science bachelor elsewhere and the master here, and if it would be more feasible to choose something else because the overlap seems rather large.
Yeah, I think it's a fair question, and also a fair thing you need to consider. If you're coming from a bachelor of material science, you may find especially the overlap at the beginning in the core program, and I think it's quite common in the part of characterization and structure and properties, because actually those 2 courses were defined specifically for the students who have the background in material science. Therefore, I am aware that it happens that to have that overlap, but it's just in this first semester. You will see that then, as soon as you start your specialization, you will have a strong deviation from your bachelor, because then you have the option to choose the topic, and will go beyond the level of the bachelor.
Okay, so basically you say it goes far more in depth than the bachelor, and therefore it is still valuable to follow this course. Thank you. I would like to amend to that like in the second half basically of this bachelor's, you have so much freedom that you just don't have in your bachelor's, that you can like really explore the things that you enjoy about material science, and not just the general material science that you've come to know and love. So therefore I would say it's definitely worth coming here if material science is really what you want to do, and if you want to specialize somewhere. Also, I can say from my own experience that our department has fantastic ties to industry, and finding an internship or a graduation assignment somewhere is so easy here, and it is so great to see how easily you can just like find opportunities to do the things you want to do. Okay, Yaisa, I think we still have 5 more minutes to answer questions. So I have a question here by somebody who wants to hear more about whether we can do more courses. What if they take more time, so more than 2 years to follow more courses? Would that then be allowed?
Yeah, it's not desired, but yeah, there are cases. I know students who wants to maybe go abroad, or I think the experience I have seen is not so much to make many courses, but maybe to have a second external research project or stay abroad, because they get the opportunity to go to CERN, for example. I remember some cases, or have students going out there in Frankfurt because there was an opportunity to do an internship. Therefore, yeah, their studies are getting a bit extended. But again, it should be approved by the Board of Examiners.
I got a question here about courses on additive manufacturing. Are there any courses from TU Delft, and can we follow them during our degree? And if you are aware of them, of course.
In our department, I just go first for the master. We don't have a specific course in additive manufacturing, although I know for certain courses you will see maybe some bits of additive manufacturing. I don't remember now from the top of my head specific courses, but I know there are courses in aerospace. There are probably some courses in additive manufacturing, and I think also in biomaterials, because they are doing something. But I think so. Yes, there are some courses or part of courses which cover additive manufacturing.
Thank you very much. Yes, I'm not entirely certain if, as a non-TU Delft person, you can also look into the study guide, right, and see this. So just so I can refer these people there.
I think so. I think so. You can check it.
I'll put an announcement in the Q&A in a moment, guys, with a link, and there you can like search for courses yourself if you want to look if there are specific courses that you can follow.
Yeah.
I got a question here about material science alumni. Do they ever apply? Oh, a bachelor's. Oh, okay. If people from material science sometimes apply for a PhD directly here in Delft from the bachelor, so skipping the master stage, do you think that's possible?
If I understand, the question is if it's from bachelor going directly to PhD.
Yes, that's the way I understand the question as well.
My right away answer is no, because normally for a PhD you should have the master level, but I don't know if there is any exception case, or maybe I don't know exactly.
Okay, me neither. And then a follow-up question to that: what's the like the stream flow between master and PhD? So do we have alumni from our own department that will also graduate in their PhD from our department? And is this kind of streamlined, or yeah, what do you think?
Yeah, we have as you mentioned, there is a percentage, 20% of students who decide to follow a PhD, and I think for that maybe 5 or 10% stay in our department. Doesn't mean that this is a straightforward step. Is that sometimes there are vacancies in our departments and can fit the profile of these master students, and the others actually goes abroad. And I can give you cases from 2 master students who graduate with me, and now one is in Paris and another is in Germany starting their PhD.
Perfect. I think so far this is it about the questions. Guys, if you have any more questions, feel free to email us. Yaisa, I think you had like the emails up, right?
Yes, just email to the MSc coordinator of 3ME. You will find it also in the website. We will try to answer you in that, or address you to the right people.
Exactly. And if you have any personal questions, feel free to send an email to the study association that I'm in the board of, to Balkijn. You can find our email address on the website of Material Science and Engineering from Delft. And yeah, we'll try to do our best to find. Yes, I have the question. If you can show the email addresses again.
Yes, I will. I need to share the screen probably as quickly. We, from a student perspective, like from the study association, we will do our best to answer like your personal questions, like what is living in Delft like, and those kinds of things, and like what can you specifically do here. And if you have more questions like, oh, I followed this and that degree in my bachelor's, it's better to actually contact our study coordinator, Saskia. I have one last question here that I'm going to answer, and that is the male-female ratio. And as a physics as a physics bachelor student, I can say I'm very positively surprised by the male-female ratio. I'd say it actually in our year, it approaches like 50-50, right? It's something like 45-55% or something. Indeed, indeed. We have a good ratio between the students, and also I have to say between the staff member, docents, and so on, it's also quite high around the just docents is 40% female, 60 males, and researchers is even 50-50, I think so.
Yeah, exactly. So I coincidentally, I had to read up on the numbers lately. Like we are actually the department with the highest number of female scientific staff in TU Delft. So girls, don't hesitate to come. Like we are very welcoming, and like there's like among scientific degrees, and especially like this is a master's of mechanical engineering. Like I'd say this is an unprecedented amount.
Indeed, I think when you compare with mechanical engineering, yes, it's a quick, big change.
Yeah, I think that was it. I'm sorry, Somnath. I'm not going to go into detail on your question. You can send me an email. I sent you my email address. And other than that, I think we are good. So we have to make room for the next presentation. Thank you all very much for attending. Thank you, Yaisa, very much for presenting. Thank you, Timo, for hosting us. And I hope you all have a good night, and hope to see you next year, right?
Yes, hopefully see you. Bye-bye.
Bye-bye.